Welcome to a lesson with Dr. Powell. Let's look at this 4 by 4 Vandermonde matrix and let's consider its determinant. The procedure that we'll use to find the determinant can easily be extended to the general case. We're going to be doing some column operations. All right. First, let's take this first column, multiply it by x1, and subtract it from here. So when we do that, we'll get 0 here because we multiply this by x1 and subtracted. And we get minus x1, minus x1, minus x1. Let's go on to the next guy. Now, here, what we're going to do is we're actually going to take what we had originally over here for the second column, multiply it by x1, and subtract it from this. So in other words, take this column right here, multiply it by x1, and subtract it from here. So x1 times x1 is x1 squared. That'll get rid of that guy right there. So then we have x1 times x2, so minus x1, x2. Then we have x1 times x3, so minus x1, x3. We have minus x1, x4. Okay. Now, let's factor out this, the x2 here, x3 here, the x4 here. So we end up getting around x2 here, we'll have x2 minus x1. Here we'll have x3 minus x1. And here we'll have x4 minus x1. We can kind of already see a little bit what's happening here. We notice that right here, we have, this is a multiple of x2 minus 1. This is a multiple of x2 minus 1. Now we're going to change this column. So again, we get another multiple of x2 minus 1. We'll have multiples of x3 minus 1, multiples of x4 minus 1. So what we're going to do here, similarly, we're going to take x1 times this column right here and subtract it from this one. And in a similar manner, after subtracting, this will go away. We'll be able to factor and end up getting x2 minus x1. Here, we'll be able to make that computation and factor. And similarly over here. Let's review what we were doing in this column. So essentially what we did is we took this guy, multiplied it by x1, so x1 times this column, and subtract it from that one. So like in this position, this would have been like x2 cubed minus x1 times x2 squared. And notice that when we factor, we would get that. And similarly for these other guys. So what we've just done is we've changed the computation to the determinant of this matrix, which will simply be this determinant in here. So this determinant now is the determinant of that. Now what we can do is we can think, okay, this row has been multiplied by x2 minus x1, so we can factor that out and say the determinant is multiplied by x2 minus x1, where we factored, and let's actually factor out that. And so then we'd be left with a 1 here. That would go away. That would go away. Okay. And then right here, we see a factor of this row. We can factor that out and put it in the determinant calculation, x3 minus x1. And this row would simply be 1 x3 and x3 squared. Okay. Then in this row, we factor out the x4 minus x1, and we just get this. Now notice what we're getting. We're getting a smaller Vandermonde determinant. And look, okay, yeah, and right here, so we can kind of apply what we've done inductively. What did we get out before? What we got out was, so x2, x3, and x4 all subtract, where we're taking, where we subtract x1. So we're subtracting x1 from everything, every x with an index here that is bigger than 1. Next time, we're going to be doing it with x2. And so we'll end up getting, so continuing out the computation, we'll end up getting x3 minus x2 and x4 minus x2. And then we'd be left with the 2 by 2 here. And in like manner, the thing we'd be factoring out is things, so minus x3, and things that are bigger than it, that's just x4 minus x3. And then we'd be done. This would be the determinant, because we'd just be left with something with a with a 1, 0, 1 in the calculation at that point, just continuing on the process that we were just doing. So what we see is that the determinant is simply the product where, let's see, of xj minus xi, where j is bigger than I. And that is the determinant of the matrix. In fact, this is general, because the idea that we just saw, we did for a 4 by 4, is easily extended beyond. So really take any Vandermonde matrix and we can use this product to compute its determinant. Thanks for watching.